Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we're going to round out inverse trigonometric functions by talking about how you can apply inverse trig functions in application problems. And these will not all be applications, but it's just a couple standard applications you would see in a trig course. Now, it is assumed that you're familiar with inverse trig functions at this point and you know how to deal with them. These applications tend to be a little bit easier than the theoretical or the standard inverse trig problems out of a textbook. And the main reason why is because often in applications, the angles you are working with are acute angles. So they're less than 90 degrees, greater than 0 degrees. And so finding their values tends to be a lot easier. All right, so in a right triangle where C is the hypotenuse, if C is of length 5.678 feet and A is of length 4.567 feet, find angle A. Well, obviously you'd like to draw a picture of this situation. So here's a right triangle, or supposedly a right triangle. The side that's the hypotenuse, we're going to call C, that is 5.678 feet. And we'll go ahead and maybe label this angle A and call this side A right here. This is 4.567 feet. And the question is asking, what is angle A? Well, this angle right here, what trig function relates that angle to the two knowns? And if you said sine, you would be absolutely correct. The sine of angle A, which I'll write this way, should equal opposite, 4.567, over hypotenuse, 5.678. And you can then just find the angle A by taking the inverse sine of that ratio. So sine inverse of 4.567 over 5.678. Now, I do want to mention here, I can just directly do this because remember, the inverse trig functions, they'll always, if you have a positive ratio, they'll always return an angle in quadrant 1, or in other words, an acute angle. And in applications, you're not going to have ratios that are negative. You're going to have ratios that are positive. And so in this case, or in applications, you can just quickly just take the sine inverse of both sides, for example, in this case, and whatever angle is returned is the actual angle that you're concerned about because it's an acute angle. All right, so let's go ahead and grab a calculator and figure out what the arcsine of 4.567 divided by 5.678 is. I'll go over to my calculator, which is right here, and I'll do the arcsine of 4.567 divided by 5.678. And we get 53.5 degrees. I'll write that in here roughly, 53.5 degrees. There you go. So that would be the measure of this angle right here, 53.5 degrees. Very fast, honestly. Applications involving inverse trig functions, not too bad. By the way, I didn't mention it, but this is called part 2 because part 1 occurred way long ago when we first learned right triangle trig. So part 2 is now that we know how to find angles using inverse trig functions, we can complete that. So our last example, second and last example, there's not, the height of a right circular cone is 25.3 centimeters. So what is first of all, a right circular cone? A right circular cone is like a traffic cone, right? You have some type of base that's circular here, and it is what we call an isosceles cone, right? So it's supposed to be not tilted, but it looks tilted to me. Maybe I should draw that again because that looks terrible. I really don't know if that's any better. But anyway, that's a cone, all right? And they tell us that the height of this cone, so the distance from the top all the way down to the bottom here, is 25.3 centimeters. 25.3 centimeters. It's supposed to be a cm, but something happened there. There we go. And the base's diameter is 10.4 centimeters. So the distance from here all the way to here is 10.4 centimeters. That's the diameter. What angle does the side of the cone make with the base? So we're really asking, what is this angle right here? So I want to know what that theta is. So how do you do a problem like this? You need a right triangle out of this, and that's why we called it a right cone, is because it is a if you draw an altitude from the apex down to the ground, it splits this cone into two similar triangles, is what I should say. So I'm going to go ahead and redraw that two-dimensional piece. I'll just draw it right here. And we know the height of that triangle is 25.3. 25.3. We know this distance right here is not 10.4 because 10.4 is the diameter. That distance is the radius. This is 5.2, and here's theta. And we want to know what that angle theta is. So again, we ask the question, what trig function relates the unknown to the two known sides? And if you said tangent, you are absolutely correct. The tangent of theta is opposite, 25.3, over adjacent, 5.2. And this will imply that theta is the tangent inverse of 25.3 over 5.2. Now, technically, again, this would be theta hat, or in other words, the reference angle. But because our angle here is within a right triangle, it must be an acute angle. So it's going to be between 0 and 90 degrees anyway. So why don't we just call it theta? Because again, tangent inverse of a positive ratio is going to return an angle in quadrant 1, which is an acute angle, which is exactly what we want. Very rarely are you going to even have to worry about the quadrants in applications, but it does occur. So I don't want to lie to you and say it doesn't. Let's go ahead and grab a calculator and find out what the arctangent of 25.3 over 5.2 is. So arctangent of 25.3 over 5.2, 78.4 degrees. So I'll write that in here, roughly 78.4 degrees. All right. And that's what this angle will be right there. So the applications tend to be much faster than the theory work, if you've seen the other videos in the series. All right. I highly recommend, again, with inverse trig functions, practice, practice, practice. The more practice you get, the better you will be at it, just like anything in mathematics.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.